Hi everyone, hope you're all doing well and you're rested after your break, and we're all ready to go with our first lesson for today. So we're going to be looking today at reflection, which hopefully everyone will have heard of before, and this new phenomenon called refraction. So let's have a look at our learning intention and success criteria. So learning intention today to examine the law of reflection and to explore the diffraction of light. And hopefully by the end of the lesson, you'll be able to state the law of reflection. You'll be able to determine the reflected or incident angle when you're provided with the other. So if you're provided with the incident, you'll be able to determine the reflected angle. When you're provided with the reflected angle, you can determine the incident angle. And finally, you'll hopefully be able to describe refraction and how it affects a beam of light entering or leaving different media. That could just be going into a glass block, a perspex block, leaving a perspex block, some glass, could be an acrylic block, it doesn't really matter, just entering or leaving different media. So let's start off with some facts about light, just a couple of quick wee facts here for you. Light, first of all, always travels in straight lines, and that's really important, because whenever we go to draw the path that light takes, we need to draw it as a straight line. To do that, we need to use a ruler. There's no other way around it. Doesn't matter if you think you can draw the straightest line without a ruler, you will still lose if you do not use a ruler. There's going to be marks somewhere at some point in your career in physics where you're going to lose a mark if you don't use a ruler to draw a straight line to represent a ray of light. White light is made of all the colours of light, so that's all the colours in the rainbow essentially, and that's essentially where the rainbow comes from. We tend to define these as red, yellow, green, blue, indigo and violet, and of course there's everything in between them as well. They just all kind of blend from one into another. And finally, the last little fact here, light can be reflected by an object, and the colour that we see an object to be basically is determined by the colours of light that it reflects. So it's going to absorb some of the light, it's going to reflect some of the light, and that's what determines the colour that we see. So drawing a ray diagram. Now this is really important. If we want to draw a ray diagram, we need to be able to do things from this ray diagram like measure angles and things like that. So we need to make sure that we do this quite accurately. So we're going to watch a little video just now on drawing ray diagrams. So what we do, first of all, is we need to draw where our mirror is going to be. So what you do is you just take your paper, you put your ruler down. I would normally just use a ruler here. I've used the mirror itself, and all I'm going to do is just draw a straight line along that straight edge of the ruler, as you can see here. So we draw that straight line along the edge there, and that just represents where the mirror is going to sit in our diagram. Obviously we're using a mirror here, so we're going to be looking at reflection first. Now normally I just put wee lines on the other side here, and that's just to help me remember that that's where the mirror goes, it's not anything else in this diagram. And of course I always label my diagrams just to make it clear to everyone else as well. Now the next thing we need to do is we need to add in a line at right angles to this line that we've drawn already, so where our mirror is going to be. This line has a special name, it's called the normal. So we draw this in, and we draw it as a dashed line normally, or a dotted line. And we draw that in as you can see here. So we draw that line in there, and that is what we call our normal. Now the normal is really important because that's where we measure any angles from. We normally just abbreviate normal to N in diagrams, however we can write it out in full as well. Now we're ready, we can shine a ray of light in. So we get a ray box, we can put in a single slit into a ray box. There's a ray box there, and what we can do is we can just pop a single slit there. You can see the single slit there. There's 3 slits on the other side, however we're using the single slit just now, and you can see that we have this ray of light travelling in a straight line. Notice that's a straight line, and all we want to do is we want to shine that towards the mirror. Now what we can do is we can put our mirror on this line here, and if we just angle that down slightly, you can see the reflected ray of light. Now you notice when I had that light coming in, I shone it right to the point where that normal meets the mirror. That's really important that we do that. Now if we want to draw this as a ray diagram, the easiest way to go about this is actually just to draw a ray of light in beforehand. If we were looking to measure angles, we could measure an angle, we could use that angle to have a precise line at a precise angle. That'd be absolutely fine. In this case, I'm just drawing a line in at any angle. I'm not hugely concerned what that angle is. So I draw that line, and then what I can do is I can shine the ray of light along there. Now it's important when we draw our rays of light that we draw a little arrow on them so that it's basically showing us which way that ray of light is travelling. Otherwise we've just got a line. We don't know whether the ray of light is coming in or the ray of light is leaving. Now I put my single slit back in, I can just shine this ray of light along. There we go. I'll just straight along that line there. It comes straight in to where that normal meets the mirror, and then we put our mirror back in. Again, angle it just downwards slightly, and we see a reflected ray there. Now if we draw two little dots along this reflected ray of light, then what that allows us to do is it allows us to then come back and draw in our reflected ray. So I just line the mirror up like so, and if I can get my head out of the way, you'll see the reflected ray of light coming out there. Again, another arrow on there just to show exactly what's happening. Excuse me. Now, what we can now do is we can use this diagram to measure different angles as we see fit. So we could measure this angle in here, we could measure this angle here, and we could maybe determine a relationship. Excuse me. Now, if we were in class at the moment and we were able to, what we would do is we go away and we do an experiment based around this. You would measure different angles coming in. We call this the angle of incidence, I should say, and here the angle which is between the normal and the ray of light that's coming in, so in incidence. And we would measure different angles in here, and we would shine the ray of light coming in, and we would look and see what happens to the angle of reflection. That's this angle between the normal and the reflected ray of light. Important to note that we always measure our angles between the normal and the ray of light. I've said this already, but it's important that we remember that. I'm going to say it again and again because no doubt someone's going to forget that at some point. Okay, so reflection. The law of reflection. I'm going to get you to copy this bit down. So what I'll do is I'll read through this, I'll kind of describe what's happening, then I'll get you just to pause the video and you can copy out these notes. So we have a mirror here, and we add in our normal. Remember, normal is really important. I'm just going to label this fully just by writing the word out in full. I would suggest you do the same at this point in time just because you're getting used to these diagrams and you need to get used to these terms. We have a ray of light which comes in. Notice there's an arrow in there and that is a straight line. And reflected from there, we have our ray of light coming back out. So the important bit here, the angle of incidence, you would have determined this yourselves, I should say, if you had managed to do the experiment. You find that the angle of incidence, remember that's this angle between the normal and the ray of light coming in, is always equal to the angle of reflection. That's the angle between the normal and the ray of light leaving the mirror. Okay, so let's just write that in. So we normally call angle of incidence I, and we would normally call the angle of reflection R. So we can write that out just as a little equation there. I is always equal to R. The easiest equation you're ever going to come across in physics. If you know what the angle of incidence is, the angle of reflection is just exactly the same. If you know what the angle of reflection is, the angle of incidence is always the same. Now, just to be completely clear and really annoying, I'm going to just repeat this again. Always, always, always measure your angles starting from the normal. So the normal is 0 and you measure round to your either your line coming in, your ray of light coming in, or your ray of light leaving. So it's always from the normal. Normal is always 0. So I'll give you a chance now just to pause the video just now. I'd like just to get a wee note of this. If you'd rather not pause the video, if you've got a wee kind of a symbol in the middle of the screen that's kind of stopped me from seeing things. I will also put the PowerPoint up here separately, just so that you've got all that information in there. You can actually just copy it straight from the PowerPoint if that's easier for you. So I'll let you pause the video now. And now that we're ready to go again, refraction, we're going to introduce this idea of refraction. So I'm going to put in this glass block. This is just a glass block, and it could be any kind of glass or plastic or something that light can basically pass through. I'm just calling it glass just now. It could be glass, perspex, could be acrylic, could be anything. So what we've got here is we have, obviously out here we're going to have air. This is a glass block or a perspex block or whatever it's made of, and then we've got air on the other side. So what we have is we have a ray of light, and it's going to come in here and it travels through our glass block. Now as you can see, as it enters the glass block, it seems to change direction, and then as it leaves the glass block, it seems to change direction again. In order to fully understand this, we need to draw in normals again. Normals are really important whenever you're drawing these types of ray diagram. So I'm just going to add in normals here. Now rather than, because obviously with the mirror, the ray of light was reflected, in this case obviously the ray of light travels into the block. So I just draw my normal going straight into the block and straight out of the block in that case. And what we see, the ray of light comes in at an angle to the normal. What happens is, as it enters the block, the ray of light bends towards the normal, and then as it leaves again, it bends away from the normal. Now, it's important to notice, you might be able to see it from this diagram, it might be kind of difficult to see, but this ray of light here actually becomes parallel with this ray of light here. So it basically leaves the block travelling in exactly the same direction that it came in. It's just kind of shifted over a little bit, okay? Now, why is this happening? Sorry, I should have labelled my normals. Let's just pop them in there. So why is this happening? What is this thing called refraction that's doing all these weird things? Well, let's zoom in on that diagram here. Right, so we've got our boundary. This is either us entering the block or leaving the block. It doesn't really matter which. We've got a ray of light coming in. Now we've zoomed right in on that ray of light, so it looks much thicker now. Just exactly the same thin ray of light that we had in that previous diagram. Now, if I draw a line here, right, this just represents the beam of light as it's travelling in towards the boundary. Now, as it's travelling towards the boundary, you'll see it reaches the boundary there. Now, at this point here, the ray of light has started to enter the boundary here. However, at this point, the ray of light hasn't started to enter the boundary yet. So what's happening here is the ray of light is actually, it's either slowing down or it's speeding up. It depends whether it's entering or leaving the block. So if we have this ray of light entering a glass block, then it starts to slow down at this point here. However, at this point here, it's still travelling at the same speed it was initially. That's the speed of light. So what happens is this bends towards, this is moving faster, so it starts to bend towards, because this side is moving slower. And if this is leaving the glass block, and what happens is that this side here speeds up and it bends away. So this side will speed up. This side won't speed up yet because it's not left the glass block until it reaches this point here, and it bends away from the normal. So just to recap, if we are in air and this is glass, it starts to slow down at this point here as the ray of light starts to enter, but at this point here, the ray of light still has to travel all this distance here before it enters the block and starts to slow down. So this is still going to travel at the same speed. This is going to be travelling slower now, this bit of part of light here. And so that's what causes it to bend towards the normal. If we're leaving the glass block, so if we've got the glass block here and this is air, the ray of light speeds up here because it's already travelling into air. It's not being slowed down by the glass block anymore. However, here the ray of light is still being slowed down by the glass block, and this part of the light has to reach the air before it can speed up, and that's what causes it to bend away from the normal. So we're going to do another couple of little notes. Again, I'll give you a chance to pause at the end of each of these slides just to let you get this information down. It's important you get the diagrams down. I should have probably said that at the last one. Make sure you get the diagrams down as well, because they are an integral part of the note. And make sure when you're drawing the diagrams you use a ruler. If you don't have a ruler, just find something with a straight edge. Sometimes a book can be useful, but obviously be careful, you don't want to damage the book. Anything with a straight edge will be good. As long as you can draw straight lines, that's what's important. So here we've got our air glass boundary. We just call this a boundary. This is basically where we're moving from air into glass. And we have our normal. Always sketch in your normal. Normal in any ray diagram. You can't have a ray diagram and be able to explain it without a normal. We have a ray of light coming in. We have a ray of light leaving. So our note that we need to write down: when moving into a glass block, the light slows down. If the ray of light isn't travelling along the normal, and we'll come back to discuss that in a minute, the ray of light will bend towards the normal as it enters the glass block. So if we have this angle here, I, which is just the angle of incidence again, and this angle here, R, which this time is called the angle of refraction. I know that can be a little bit confusing. We use R for the angle of reflection or refraction. It just depends on what the light's doing, whether it's reflecting or refracting. We can say that the I, this angle of incidence, is greater than the angle of refraction. Again, I'm going to say it again just because we need to be really clear on this. Remember, whenever you're measuring your angles, always measure them from the normal. So you'll notice here that I've started at the normal and I've measured to the ray of light coming in. And you'll notice here that I've started at the normal and I've measured to the ray of light leaving. I'll give you a chance to pause just now. So you pause the video. Again, the slides are up there. If you'd rather come back and then copy the notes out afterwards, that's absolutely fine from the slides. I'll make sure that they're on the Google Classroom with this video. So pause just now. And then we're ready to move on. So if we move on to glass into air. So this is moving from glass into air. I'm going to get you to copy this down again. Again, the diagram is vitally important to this. So we've got our glass air boundary. This is the other way around now. So we've got glass on this side, we've got air on that side there. We have our normal. Again, can't do a ray diagram without a normal because you can't explain what's happening. We have a ray of light coming in. We have a ray of light leaving. So here's our note. When moving out of a glass block, the light speeds up. If the ray of light isn't travelling along the normal, the ray will bend away from the normal as it leaves the glass block. So let's just have a little look at that. So I, our angle of incidence. This time we've got R here, which is our angle of refraction. So in this case, I, our angle of incidence, is less than our angle of refraction. You guessed it, I'm sure already by this point. Remember and measure your angles from the normal. I'm going to say this loads and loads of times over the next couple of years. Okay, but it's always from the normal. So I've started here, I've measured round to the ray of light. So I've started at the normal, measured to the ray of light, started at the normal, measured to the ray of light. If I were to have measured this angle in here between the glass and the angle here, that's the wrong angle. That would cost me marks if I was answering a question on it. So it's always this angle in here and this angle here. Okay, I'll give you a chance to pause at this point in time before we move on. Finally, I'm going to get you to just write down a little note on a special case. What happens when the ray of light travels along the normal? Now, I've said obviously when it comes in at an angle to the normal in these previous two notes. We're just going to have a little look and see what happens as it comes in travelling towards the normal. Now, this is a nice easy one because it's exactly the same as if it's entering glass as if it's leaving glass. So if we are starting in glass and travelling into air, or if we're starting in air and travelling into the glass block, it's going to be exactly the same. First thing I'm going to do is draw in our normal, and we'll have a ray of light coming in. Now, a ray of light this time is just coming along the normal. You'll see it's just travelling straight along that normal. And leaving, we have the ray of light travelling exactly along the normal as well. So maybe you'll have guessed it, our note is going to say basically, when travelling along the normal, the ray of light does not change direction. When entering or leaving the glass block, the light continues to travel along the normal. Simple as that. So there's no angle of incidence, no angle of refraction here. Okay, so success criteria here. Now, before I get you to do the success criteria, I'm going to ask you to do something for me. Once you've finished writing in that last note, I'd like you just to take a picture just of that last note that you wrote. I don't need you to take a picture of them all. And I want you to submit it here. I've created this as an assignment so you can, in the Google Classroom, so you can submit it as an assignment. Now, I'm the only person that can see it when you submit that as your submission for the assignment. I just want to kind of make sure that you're able to draw these diagrams properly. So I just want to have a look and see kind of what you managed to get down. So I'd like you just to kind of take a picture on your phone, if you can, of the of that last note, and then just submit it here as an as your response to the assignment. Okay. Now, hopefully at this point now we are able to state the law of reflection. You can hopefully determine reflected or incident angles when you're provided with the other, and hopefully you will be able to describe refraction and how it affects a beam of light entering or leaving different media. So that's us. As I said, if you can upload a picture of that final note for me, then, as I said, just put it in with the assignment. It doesn't need to be public. I just need it in there, just in that way it's assigned to yourself. That means that I can see, first of all, who's taking part in the lesson, and secondly, who or how you've managed to get on with that. I can also provide you with a little bit of feedback if there's anything that I kind of wouldn't be happy with, or that I think might kind of cause you problems in the future. Okay, so that's us for today. I will see you again tomorrow.